Okay, in this we will divide a polynomial by a monomial. We should already know what's a polynomial and what's a monomial. Okay, um, so to add, subtract fractions that have the same common denominator, we already know what to do. But let me just give that as a recap. All right, so just recall this: add and subtract fractions that have the same denominator. Okay, so the to add and subtract fractions that have the same denominator, this is what we do. To add or subtract fractions that have the same denominator, we add or subtract their numerators and keep the common denominator. And why are they common? Because they don't have different denominators, they're the same. Okay, now in symbols, for example, if a and b and d represents numbers and d is not 0, then this is what we do. For example, in symbols, this is in general, in symbols, if a, b and d represent numbers and d is not equal to 0, which is one of the key points, okay, then this is what happens. Consider, let me do that in blue. Okay, in blue, this is saying if a over d plus b over d, we keep the d and simply say a plus b, and a d minus b over d, this is saying a minus b over d. That's all that is saying. Okay, we can use this rule in reverse to divide polynomials by monomials also. Okay, dividing polynomials by monomials, let's see, let me write out a little rule there so you can use it as a guide. Divide a polynomial by a monomial. Okay, thing to divide a polynomial by a monomial. Okay, divide each term of the polynomial by the monomial. Okay, let's see. Consider, for example, if a, b and d represent monomials where d is not equal to 0, then if we had a plus b over d, that is to say a over d plus b over d. That's all that is saying there. Okay, so that is just a recall of those two basic rules. Okay, so now we're going to take some examples with numbers and variables. Okay, So once we have that understanding, so we can divide a polynomial by a monomial, add and subtract fractions that have the same denominator. We can do that. So let's go to some examples of what we want to do to divide a polynomial by a monomial. So if I tell you now, divide 9x plus 6 by 3, you need to be able to set up the problem very good. First of all, you need to understand what the problem is telling you, who's being divided by what, and what goes at top, what goes at the bottom. This is saying that 9x plus 6 will be divided by 3. So 9x plus 6 is actually the numerator. So this is the numerator and this is the denominator. So strategy, let us set up the fraction to represent the division. Okay, so as the first step, we're going to write now 9x plus 6 over 3. That's our strategy. Then we divide each term of the numerator by the new denominator. Why? Because this is the rule for dividing polynomial by a monomial. Okay, so now we end up and we expand it and we say 9x over 3 plus 6 over 3. Divide each term of the numerator by the denominator. Now remember, we just did simplification, so this could be written as to say, so let me just do it on this side, so we now go down there. So 9 is actually 3 times 3 times x over 3 plus, and 6 is actually 2 times 3 over 3. This could cancel out these 3's, this one of the 3's there, and so we end up with 3x. So 9x divided by 3, 3x. 2. Why? Because 6 divided by 3 gives us 2, and that's our solution. So this is how we divide. All right, let's do our next example on this one here. So divide 4 minus 8b over 4. Okay, so if I don't tell you by words divide by, you need to understand that this means the division. So we end up 4 over 4 minus 8b over 4 equals 4 divided by 4, 1. 8b divided by 4, well, 8 divided by 4 gives us 2b, and that's our solution. Okay, so that's not difficult, it's just that you need to break it down. Okay, so we end up with that particular problem there. So notice that one there, we can expand out if we want, or we could just go straight to your problem, divide right away. So let's go with some bigger values now. So these big values are as follows. I tell you, divide 9a squared b minus 6ab squared plus 3ab over 3ab. So do we have a strategy? Yes, we will divide each term of the polynomial in the numerator by the monomial in the denominator. Okay, this is the rule for dividing a polynomial by a monomial. All right, so let's break it down. So I'm going to do it down here so because I can fit. So we have here now, we put 9a squared b over 3ab, keep that top sign, negative 6ab squared over 3ab plus 3ab over 3ab. Okay, so we are dividing each term of the numerator by the denominator. So now the next step is as follows: 9 divided by 3, 3. A squared divided by a, well, let's put the rules of division, and then we have b 1 minus 1, and 6 divided by 3, that's 2, and we have a 1 minus 1, and then b 2 minus 1 because these are single b, and then we have plus 3 divided by 3, that's 1, and then we have a 1 minus 1, and we have b 1 minus 1. Okay, so now the next step is as follows: the 3 comes down here, and a to the first and b to the 0. This gives us now minus 2 a to the 0 b to the first. Next one plus, well, that's still 1 a to the 0 times b to the 0. Okay, but here you need to recall that, let me write that down, okay, that a base to a 0 power, it is always equal to 1. So recalling that rule, we have the next step to say 3a, this goes 1, minus 2, 1b, and then here plus 1, because this is 1 times 1 times 1, and so our solution would then be this one here. Okay, so that's not difficult. So let's try another example, and these are where we get more complicated polynomials. So our next example is as follows. Divide 14p cubed q plus pq squared minus p over 7p squared q. Break it down into its components. Okay, singling them out, each top term by the bottom term. So this gives us now 14p cubed q over 7p squared q plus pq squared over 7p squared q, and then minus p over 7p squared q. Okay, so we have just set up the problem. Sorry about that. Just set up the problem. Okay, so now we proceed. We start to cancel whatever we could cancel. If you notice the steps, we're going to be shortening them so that we need to get more into that practice. So this gives us now 14 divided by 7, that gives us 2. P 3 minus 2 gives us 1, and Q 1 minus 1 will give us 0, which is 1. Then we get plus, well, the 7 cannot be divided into anything, so the 7 stays underneath. P, take away one of the p's here, well, the p's would cancel out. That would give me still a p at the bottom and a q at the top, because the q would cancel one of the q's up there. And then minus, well, the p would cancel out here, so we're left with 1 at the top, 7pq, and that's our solution for that one there. Okay, so let me go over this one here again. Notice here that this p is squared. Okay, so what did we cancel here? P is squared here, and then there's a single p at the top. So when I cancel one of the p's from the top with one of the p's at the bottom, I am left with one of the p at the bottom. And then there are two q's at the top and a single q at the bottom, so we are left with a q at the top. Okay, and then on this side we have p canceling with one of the p's at the bottom here, leaving me with a single p, q, 7. So that's our solution. We cannot go farther than that, because that's the problem which we were given. Okay, now let's go to some problems where we start to get a little more complicated. And so we see this problem here. I have it zoom as much as possible so some people could see it. So we say here, divide x minus y open close bracket squared minus x plus y squared over xy. Let us say something about this strategy. We'll remove the parentheses in the numerator, this parenthesis, and collect the like terms. Then we will divide each term of the polynomial in the numerator by the monomial in the denominator. Okay, why? This is the rule for dividing polynomials by a monomial. That's the rule. Okay, so let's expand out the top piece. Equals, this gives us, well, we already know what to do here. We square the first term, x squared, and then we say 2 times the product of the two terms, which gives me negative 2xy, and then square the second term plus y squared minus, let me go over this piece here. I said the first term squared, and then I said 2 times x, 2x, times negative y, negative 2xy, then negative y times negative y, positive y squared. So now we put minus open bracket. So x will give us x squared, and then 2 times x times y will give me 2xy, and y squared will give me y squared. There. Now we need to get rid of the bracket. Remember, we're doing this at the beginning also of the of multiplication. So it gives us x squared minus 2xy plus y squared. Remember all this, we write the bottom one, xy in blue, and we end up with here, everyone inside will change sign, x squared minus 2xy minus y squared over the xy. Okay, now is there anything that will cancel? You cancel them right away, don't waste time. Well, we have the positive x squared and negative x squared, they cancel with each other. Okay, we have positive y squared and negative y squared, they cancel with each other. So now we have negative 2xy, negative 2xy. That gives us now, as our step, negative 4xy over xy. Here we can expand to one more step, and the xy and xy cancel with each other, giving us negative 4 as a solution. So that's our solution for that one there. So not because the problem looks complicated, it means you will have some complicated solution. No, you just have to apply the rules. Now if you notice, we apply this one here, we expand out, this one here we expand out, then we combine them and we left the bottom piece by itself last, and then we start to divide them when we could cancel out, so we have less terms to work with. Okay, so that's for this topic here.